Hello guys, welcome to Color's Introduction to Virtualization Platform. A3C Case is a virtualization platform launched by A3C for enterprise and industry data centers. We use Case, this virtualization platform. We can reduce the number of data center servers, integrate data center IT infrastructure resources. We can simplify IT operations because we just use the GUI management page to manage all the devices, hardware, and the virtualization platform. So we simplify IT operations, can improve management efficiency, and achieve the purpose of improving physical resource utilization and reducing overall cost of ownership. Through this course, you will learn the evolution history of server virtualization, and you will learn more about virtualization. You understand the technical advantages of case virtualization, and you can learn typical cases and application scenario of case virtualization. Okay, the first part. Let's see what is virtualization and why we choose this way to build our case virtualization platform. So let's come to the evolution of server virtualization applications. The origin of server virtualization can be traced back to the late 1950s. In June 1959, an academic report called Time Sharing in Large Fast Computers first proposed the concept of virtualization. This is considered to be the earliest discussion on virtualization technology. In 1972, IBM released a virtual machine technology for creating flexible mainframes. This can quickly and efficiently use various resources according to dynamic needs. At this point, virtualization has officially entered people's field of vision, and virtual machines have become very popular in mainframe area. However, for most companies, mainframes are expensive and unaffordable. Therefore, after the birth of Unix, many computers developed rapidly under the impetus of risks, that is, reduced instruction set computing, RISC. Use this RISC technology. The technology of mainframe began to be gradually transplanted to the mini computer or Unix server. RISC server and mini computers have also become beneficiary of virtualization. With the popularity of x86 architecture in the 1990s, this situation has finally changed. More and more people are modifying the instruction set of the x86 processor, coupled with the emergence of multi-core processors, making virtualization technology develop rapidly on the x86 platform. But there is a problem. The original x86 architecture was not suitable to virtualization. So you know why? Let's see. In order to prevent the error code of the application from destroying the entire system, most CPUs are now divided into two or more states. Some instructions can only be executed correctly at the highest level, while execution at a lower level is prohibited. According to different operating levels, the CPU instruction set can be divided into two categories. One is privileged instructions. This level can only be executed in the highest level state. Execution in the lower level state, such as user mode, will cause an error. For example, the instruction LIDP can only be executed in the system mode. In other modes, an error will occur and the execution will be aborted. 2. The second is about non-privileged instructions. This can be executed at various levels. In addition, we also call the instructions that affect the configuration of system resources as sensitive instructions, such as reading sensitive registers or memory according to all I/O instructions. Virtualization technology requires all sensitive instructions to be privileged instructions. But unfortunately, in the original x86 architecture, some sensitive instructions are not privileged instructions. When these instructions are executed, traps are not automatically generated and captured by VMM. This hinders the virtualization of instructions. So now you know why the x86 architecture was not actually suitable for virtualization. Okay, in order to solve the virtualization problem on the x86 architecture, three mainstream technology have emerged. That is parallel virtualization, full virtualization, and hardware-assisted virtualization. So, you know what is our S3C case, which one we use. You can take these questions within our explanation here. Then you tell me your answer. Okay, the first, that is parallel virtualization. This type of virtualization can be stored as a management VM running next to the guest VM. Citrix calls it the special VM DOM0. Hyper-V calls it the parent partition. The virtual machine guest OS is also called DOM-U and child partition by Citrix and Microsoft respectively. Management VM is responsible for all input and output device drivers on their hardware platform. In other words, the hypervisor in parallel virtualization does not simulate I/O devices, but only simulates the CPU and memory. This is a parallel virtualization translated to parallel virtualization reasons. For parallel virtualization also has a more common name, OS-assisted virtualization. This is because the guest VM itself does not have a device driver. You need to seek help from the management VM. Its working principle of parallel virtualization can be understood as the guest OS running on the hypervisor has incorporated the code related to parallel virtualization. So guest OS can work very well with hypervisor to achieve virtualization. Hypervisor provides hypercore interface to meet the key kernel operation of guest OS, such as memory management. Its advantage is that the performance is very close to a physical machine. For its disadvantage is that it does not support a modified operation system, so its compatibility is very poor. What about full virtualization? VMware Workstation and ESI server are typically deputy of full virtualization technology. For operating system privileged instructions that cannot be virtualized, full virtualization technology dynamically translates into a series of new instructions through binary codes. These instructions have the same meaning as the original instructions and can support hardware virtualization. Binary code dynamic translation technology dynamically rewrites the execution code of virtual machine during execution and inserts trap instructions where the virtual machine manager needs to monitor and simulate. The advantage of this technology is that GetOS can run directly on the virtual machine without modification. As a disadvantage you can see is that the dynamic translation brings certain performance overhead. The input and output of the binary code translator are binary x86 code. Some sensitive instructions are placed with trap instructions. Therefore, the working principle of full virtualization can be summarized in three aspects. The first one you can see at this slide, the GetOS instruction segment performs the entire translation before execution and replaces the sensitive non-privileged instructions with the corresponding privileged instructions in ring 0. And non-privileged instructions are executed directly. The privileged instructions is first trapped in the VMM, and the VMM implements these privileged instructions through a series of simulation operations. Okay, you can see the advantage and disadvantage here. We you just remember, and for advantage, does not need to modify it, and the OS cannot perceive whether virtualization has occurred. The disadvantage I have told you before, that is, the performance is low when the load is large and the sensitive instructions are executed frequently. So this is full virtualization, and now you are familiar with the advantages and the disadvantages of parallel virtualization and full virtualization, and you know the working principles. But for both parallel virtualization and full virtualization have three difficulties. This affect the development of virtualization. That is, large workload and difficult development. Software virtualization instructions translation code implementation workload is very large, and the development is difficult. And the second way is about the second problem is about high performance loss. Software virtualization relies heavily on VMM, and software simulation execution slow down the virtualization performance. And also, it will take technical bottleneck. Software simulation, this can be optimized and can be improved. The space is small. It is urgent to introduce new technologies to break technical barriers. So we need hardware assistance perform virtualization. In order to solve the dilemma of virtualization, hardware assistant virtualization technology comes. That is KVM, kernel-based virtual machine, is a typical solution based on hardware assistant virtualization technology. The so-called hardware assistant virtualization technology, as the SAM suggests, is to add special support for virtualization to hardware, such as CPU, motherboard chipset, and I/O device, so that the system software can implement virtualization functions more easily and efficiently. There are many reasons why it is necessary to add virtualization support to the hardware. But first, as the original hardware architecture has defects in virtualization, such as the ring deprivilege problem and the compression problem mentioned above, the binary translation technology has performance problems, and the parallel virtualization technology has the problem of needing to modify the source code of guest OS. Secondly, due to the limitation of hardware architecture, although some virtualization functions can be implemented by software methods, the complexity of implementation is very high. A typical example is the shadow page table of memory virtualization. Finally, some virtualization functions implemented by software methods have low performance, such as virtualization of I/O devices. This problem can only be completely solved by adding corresponding hardware support in the CPU architecture. Virtualization of physical resources by VMM can be summarized into three main tasks: processor virtualization, memory virtualization, and I/O virtualization. In terms of processor virtualization, Intel VT process with VXT, that is the Intel virtualization technology for x86. And in terms of memory virtualization, Intel VT provides EPT, that is Extended Page Table, EPT technology. In terms of I/O device virtualization, Intel VT provides VTD, that is Intel virtualization for direct I/O technology. Okay, let's see them one by one. About hardware assistance virtualization for CPU. How it works. Intel VTX introduces a new CPU operation called VMX. VMX, that is VM, that is virtual machine, X extensions, so that is virtual machine extensions, VMX, as well as 2 new CPU working modes and 10 new virtual special instructions. The 2 working modes are VMX root operation and VMX non-root operation. Among them, VMX root operation is designed to be used by VMM, and VMX non-root operation is used by Get OS. Both working modes support the Ring 0 to Ring 3. Therefore, VMM and Guest OS can freely choose their designed operating level. Hardware-assisted virtualization technology is realized by switching between the 2 working modes of VMX root operation and VMX non-root operation. The VMM routing in VMX root operation mode switches to the VMX non-root operation mode called VM launch or 15 VM resume instructions. The hardware automatically loads the concept of Guest OS. This conversion is called VM entry. When the Guest OS encounters events that need to be handled by VMM, such as external interrupts or page faults, the hardware automatically suspends the Guest OS and switches to VMX root operation mode, resume VMM operation, and this transition is called VM exit. Since VMM and guest OS share the underlying processor and resources, the hardware needs a physical memory area to automatically save and or restore the concept of each other execution. VTX has designed a control structure VMCS for each VM to save VM and VMM information, just like this picture shows. VTX is for x86 architecture of server, and the VTI is for Intel architecture of server. In fact, the functions of VTI and VTX have many similarities. They both use the mode VMX, you can see at this slide, and virtual machine monitor VMM is running it at its site at R0 level, and you can think it as ring 1 level or as running next to the ring. The host operating system and all programs run in VMX mode, while VMM runs in VMX root mode. It has 3 advantages here, you can see. It breaking the limits, expand the working mode of CPU in virtualized environment, and accurately distinguish the sensitive instructions issued by the virtual machine through the non-root identifier. Breaking tables, the execution of sensitive instructions in non-root mode has been redefined to solve the virtualization loophole problem. So element, introduce VMCS, you can see on the slide the red one, in the new virtualization. VMM can easily call new instructions, and the CPU automatically completes the switch between root and the non-root mode. The operating system has 2 main basic understanding of physical address memory. Physical addresses start from 0 and memory address continuity. VMM use simulation to make the simulated memory meet the 2 basic understanding of the virtual machine operating system on memory. This simulation is memory virtualization. The problem with memory virtualization is that the physical memory must be used by multiple virtual machine operating systems at the same time. But there is only one physical memory, and there is only one physical starting address 0. This cannot meet the requirement of all virtual machine operating systems start from 0. VMM here, it is responsible for managing and allocating the physical address memory of each virtual machine. What the virtual machine operating system sees is the virtual machine physical address space. The address used in its instruction will eventually be converted into a virtual machine physical address. The physical address of the virtual machine cannot be sent directly to system bus. It needs to be converted into an actual physical address by VMM and then handled over to physical processor for execution. In terms of the memory virtualization, hardware assistance virtualization technology uses extended page table, that is EPT, extended page table technology. Since the construction of shadow page table greatly reduced the performance of the VM, Intel and AMD respectively proposed the EPT technology and the NPT technology. NPT, that is nested page table. proposed the EPT technology and the NPT technology to provide hardware hardware support for memory virtualization. The principle of these two technologies are similar, and both implement the conversion from virtual addresses to machine addresses at the hardware level. The following use EPT as an example to analyze the imitation of hardware systems memory virtualization. A shadow page table corresponds to page table of virtualization operating system. The disadvantage of shadow table include the implementation is very difficult, and the various page table synchronization situations need to be considered. The memory overhead of the shadow page table is large, and the shadow page table needs to be allocated and maintained for each virtual machine's corresponding page table. So this is about the hardware systems virtualization of memory. What about I/O virtualization? This picture, you can see it shows the I/O virtualization of hardware assistant virtualization. How to deal with the I/O process of hardware assistant virtualization? So first, the client device driver launch an I/O operation request, and you can see here, and then KVM's I/O capture code intercept this I/O request. After processing, put the information of this I/O request on the I/O sharing page and notify QEMU program of the user space. After the QEMU process obtains the specific information of the I/O operation, it is handed over to the hardware simulation code to simulate this I/O operation. After completion, QEMU puts the result back into the I/O sharing page and notifies the I/O operation capture code in the KVM mode. The capture code of the KVM module reads the operation result in the I/O shared page and posts the result back to the client. It can be seen in the full virtualized I/O mode. The hypervisor must simulate the complete device hardware for the guest. In addition, when the guest accesses a very large block of memory through DMA and the QEMU simulation program does not put the operation result in the I/O share page, but writes the result directly to the guest memory through memory mapping, and then through KVM till the guest that the DMA operation is complete. Advantage here shows for I/O virtualization. There's no need to modify the guest OS. It uses the native device drivers. It can simulate some old-fashioned class equipment to solve the debugging and development programs introduced because there's not enough equipment on hand. There's also disadvantages. Long I/O paths, relying on KVM and QEMU for intermediate information process, make data copies multiple times, and the kernel state and the user state of guest and host perform context switch many times. So this is the disadvantages of this. This is our current mainstream hypervisor product. You can see just to have a brief understanding about this. So many companies, and so we introduced to you all about the evolution of virtualization, and for our S3C case, we use the hardware assistance virtualization technology. Now let's learn more about S3C case virtualization. Here shows the architecture of S3C case. In the bottom, you can see our case installed at the hardware, that is the server. And the server, we can mount the storage of IPSAN or FCSAN. Also, we support the various of storage. We just give you example IPSAN or FCSAN. And if you build a cluster between servers, we need a switch. We need a network. After we have the hardware infrastructure, we can install the case CVK on the server. That means A3C case, it has its own operating system. You do not need to install an operating system before you install the case. So key point, case its own have operating system, that is CentOS and S3C Linux. You do not need to install other operating system before you install case. And S3C case include 3 components: S3C case CVK, CVM, and CIC. CVK, K, that is kernel. Kernel, we use cloud virtualization kernel. It can build the communication between hardware and our operating system, our management of case. Through CVK, through cloud virtualization kernel, we can realize computing virtualization. We have virtual disk, virtual CPU, virtual memory. We have other functions to realize it's about computing virtualization. We support storage virtualization. We can mount different physical storage to S3C case, and you can get a virtual disk here, and if you mount, you can use shared file system, and we support different types of disks of virtual machine, vDisks, and we also support network virtualization. We support we have vSwitch. vSwitch for virtual machine, it uses vSwitch to connect it to the outside of the network. We can also configure SL, QoS, etc. So this is what the CVK do. What the CVK does. Okay, this is the first component I show you. And the other component of S3C case, that is CVM. S3C case CVM, M means manager, do the management work. It can manage. It just provide you a GUI management page, and when you log into the page, every button, you can click the button, and it will automatically execute the relevant command to the CVK node. You can manage the system. You can do the life cycle management of virtual machine, and you can do the monitor and alarm of the whole system, do the security management, do the high availability management, and so many functions you can do at the web page. So it is very convenient for our operation and maintenance work. They also provide a REST API interface. also provide the OpenStack API compatibility. So this is CVM, Cloud Virtualization Manager. So we just need to install this component, just one of your cluster of all of, just to choose one or two nodes to install CVM. That is enough. If you choose two, that is you set the failover system of management. And the last component, that is CIC. CIC, that is Cloud Intelligence Center. We can provide virtualize the data center. If you have different departments or different companies in the unified, a very big company, so you might just permit some department have give them a virtualized data center, and you can set different resources of computer resources, the storage resources to this virtualized data center, and you can give set a manager to this virtualization data center, and support for the user for the virtualized data center. You can set it supports the self-service portal, and they can apply the virtual machine or resources by them own. And for the manager itself, we design the service process. After we permit it, they apply, and it will automatically deploy. We also, for CIC, it can manage the CVM resources. It can also manage the VMware resources, and so we increase the compatibility. About the high reliable architecture of A3C case, and you can see there are many nodes at this, and they can build a cluster to realize the high availability. And there are many CVK nodes here. CVM just add the CVK node to its management platform. It can just send a different command to CVK if you type the management button here. For CVM itself, we support the failover system. You can use two CVK nodes to active and standby. If one CVK node down, the other CVK node, if one CVM node down, and the other CVM node can also provide the management service. These two virtual CVM will synchronize the data, exchange the service data. Also the configuration changes. These two nodes will run the heartbeat service. And also note, if you for the cluster of all A3C keys, it can run HA. This HA is for node, and we also support VMHA. Once a CVK node down, it can migrate this virtual machine to the other node if they have enough resources. So, brief understanding about high availability here. About CVM stateful failover, you will have a brief understanding about this. We will say the virtual IP address. That is mean you can just use this IP to access to the CVM management node. You do not for the manager, they do not concern which CVK node is a master node, which CVK node is a swap node. You just use the virtual IP to running to access to the management service. So this is a virtual IP address. And you must set the other CVK node its IP and the root password. And you will set a quorum node. It will judge whether the CVM node is active or not. And when you do the for CVM, it will store the VM and the host information and the status and the monitor information. So you need to set the database partition. And if you do not know how to calculate, you can give the estimated host quantity and the VM quantity. It will automatically give you the suggestion of database partition size. We also support to backup the CVM configuration here. About high availability for N dimension, and you can see there's CVM, there's 3 CVK node here. We mount the storage here. We can provide reliability guarantees in all around the service level from the host to the applications. Flexible configure fault detection time and fault handling methods and perform automatic system maintenance. Support the refined configuration such as VM startup priority, HA resource reservation, and designated failover host. So this is function. If you want to learn more about this function, you can read the detailed configuration guide, or you can also get descriptions at the online help here. For application scenario and value, you can see we can improve automated maintenance method for virtualization environment, reduce maintenance manpower input, minimize virtual machine service interrupting time, shorten average file back time, and improve system reliability. We support the physical server HA, VM HA, operating system HA, and application HA. So all of these high availability we can realize. We can try our best to help when someone is down, and we will detect this. And just for VM, we may reboot or migrate. And for applications, we may restart or reboot the applications to help the application or VM to restore to the normal state. You can see the application migrate. And for VM snapshot, VM snapshot for this function itself is just for temporary backup. For example, if you just want to install an application, you want to install application in this in a virtual machine, but you do not know whether it will influence the operating system of the internal VM. So you can make a snapshot. It's just temporary use. It can give you a screenshot, give you a snapshot, and if it does influence the operating system of the virtual machine, and you can restore. Just choose the snapshot and restore. After you do that, I suggest you to delete the snapshot after you've done that. For virtual machine backup and restore capabilities, We support you just backup the virtual machine immediately, or you can set the backup policy to backup virtual machine. And you can set the backup policy, you can set the location, and you can set the location directly to local or remote server. You can set the time, monthly, weekly, and you can set this recovery mode, location, and directly. About disaster recovery based on storage replication. And you can see there are two sites here, production site and disaster recovery site. And they use the same physical device, and we configure the protection group and the relevant recovering group here. If the production site down and the disaster recovery site will have the applications running well, the customer's service running well. And for the production site and disaster recovery site, it will synchronize the storage, synchronize the configuration of the virtual machine, etc. Homogeneous and heterogeneous disaster recovery solution of disk CDP. S3C case support disaster recovery based on storage replication and disk backup. Disk backup-based disaster recovery uses an agent to replicate operating system data for disaster recovery. KCVM obtains host information and captures data block changes from the agent installed on the production host or VMs, and transmits incremental data to the storage node and to recovery side, the right side, that is recovery side. If the production side fails, service can fail over with one click to the DR side based on the backup data. Case disk backup-based disaster recovery can protect the applications running on most architecture with flexible disaster recovery options. The disaster recovery service can be deployed in standalone HA or cluster mode. You can back up data of multiple different platforms to one disaster recovery site. So this is the disaster recovery solution of disk CDP. For case migration plan, if it is internal migration, and you can just click migrate at the CVM management platform, there's no need to apply the other permission license. And we can migrate, also the virtual machine can migrate between different case platforms. And if the virtual machine is running on other virtual platform or just running on other physical servers, at this time you can use the heterogeneous migration tool to do the migration to case platform. We support online migration. It needs a license permission. Okay, now you know the architecture of case virtualization and you know the functions of S3C case. And now let's see the third part about typical cases of S3C case virtualization. For S3C case product, it have more than 20 years to deliver this product, and we serve more than 10,000 customers. And for different different industries, government, enterprise, education, energy, healthcare, finance, and media. We do have our customers, do have our case customers. And there is a typical uh, topology here I want to introduce you. This is to create medical digital development parts that realize the province medical interconnection through the medical and health cloud platform. You can see here we have the provincial cloud. We have a city cloud, and the city cloud include many different hospitals. We use this topology to we set different levels. We build several information systems. It has laid a solid foundation for the construction and applications of future information. The province cloud can manage the city cloud, and the city cloud can have different hospitals services. For this example, it have community health center, more than 433 community health center, and for station 900 community health service station, and for ownership health center come to 2057, and for village clinic there's even more, 57,008. So it is a big scale of our customer, and we can handle them, we can support for our case product and support this. So this is all about introduction of virtualization platform. You know, the evolution history of server virtualization. We know 3 different virtualization type, and you know why we choose system hardware systems virtualization. We use KVM to realize, and you have a brief understand of A3C case product, you know, the architecture and some key functions. And we give you an example, give you a typical case of A3C case virtualization. Okay, that's for this class. Thank you for your listening, and I hope this can help you.